Hi, I'm Gerhard Clercq, and today I want to talk to you about Litterbox, my project called Litterbox, which I describe as somewhat isolated development environments. And through the course of this talk, I will explain exactly what I mean by that. So first, let's talk about the problem Litterbox solves, implicit trust. And to describe what I mean by that, let's go back to the beginning. So I started working on this project around a year ago. At the time, there were a lot of supply chain attacks out there. I think 3 big ones in 3 weeks, primarily in the NPM ecosystem at that time, but there have been many and many ecosystems since. I think a month ago there was, again, some chaos. And this basically just, to be honest, this made me scared, and it made me realize just how vulnerable we all are as software developers. Depends what you work on, but if you use any of the so-called modern languages like Rust with Cargo or JavaScript with NPM or Python with Pip or whatever, the thing is these languages have package managers, which it sounds like a good thing because it makes it trivially easy to add a dependency. The problem is what happens then is all your dependencies have dependencies and all their dependencies have dependencies and so on and so on. So you're easily in a situation where you think you have 10 dependencies, but in reality you have hundreds, if not thousands. And you're implicitly trusting all of them to not be compromised in any way. So to either not be deliberately malicious or that the developer just hasn't gotten compromised. And this is particularly scary on most modern desktop operating systems because most desktop platforms don't really give you any protection in this situation. So on desktop platforms, a process runs as a specific user, and generally it just has access to all of the files owned by that user. So any code running on your machine basically just has unrestricted to everything on your home directory, which could include SSH keys, other sensitive files with sensitive information, perhaps your browser cookies. It's kind of scary that everything running on your computer basically has access to everything all the time. On mobile, this is not generally true, but on desktop it is. And this situation is partly why these attacks became so big, because what would happen is once they managed to compromise the machine of a single package maintainer, they would then basically steal all the keys from that developer on their machine and use it to compromise all the packages maintained by that maintainer. And this way they would spread out, infecting more and more maintainers over time until it became really bad. So this is all pretty terrifying, and I didn't want to keep developing like this. I wanted to have a way to keep things more isolated. And then that is the thing that scared me. And then, another kind of similar problem showed up during the year as well, called AI coding agents. And I don't think I have to explain to anyone here what they are or what the problem is, but it's quite a similar problem in many ways. These things can basically do whatever they want. They can run arbitrary shell commands, but also they write code, and then you run that code on your computer. So they basically have access to everything as well. It has been shown that these things are very susceptible to so-called prompt injection. They can easily be hijacked for that. Then quite often these things have access to the internet. They sort of need that to get useful information, but that's quite a dangerous combination. Then they can easily get prompt injected. But that's not even necessary. Sometimes they just get derailed all on their own. So giving these things unrestricted access to your home directory is also pretty terrifying for anyone doing that, which has become quite a large thing, and I think it's almost the same problem in many ways. Originally, I didn't want to build a solution for this problem, so I set out to see if I could find a solution. And these are basically what the 3 things I could find at the time. The first one is obvious, just use like a full virtual machine. That's great because then you have strong hardware-enforced isolation. The problem is just it comes with a lot of overhead and there's poor integration. So I don't really want to have to make a full virtual machine for every project that I work on. That's super inconvenient. It's almost like making a dedicated real machine for every project that I'm working on. It just doesn't scale properly. And I have to set up each one every time. So that wasn't viable. Something I've used in the past and I found convenient is Visual Studio Code has this concept called dev containers, which are nice because then basically your entire development environment is inside a container. So you have a Docker file which sets up all your dependencies and toolchain and everything. That's nice because then it's fully documented and it's portable. The problem is just that was never really designed for isolation, so it's not particularly good at that. It requires IDE support, and the IDE itself runs outside the container. That's actually something I forgot to mention. So a lot of editors today, like Visual Studio Code or Zed or many other ones, a lot of the functionality actually comes from third-party plugins, which have this exact same problem with supply chain attacks, that they're just downloading random code and running it on your computer, and you're hoping for the best. So with dev containers, also the editor and all its plugins run outside the container, which doesn't really even have much isolation to begin with. Then something else that's interesting and similar is called Distrobox, which I've used in the past, which is not designed for isolation, but basically the idea with Distrobox is that, I don't know, let's say you're running Fedora on your machine, but you really want to install some Ubuntu packages. Then Distrobox is a tool which uses container technology to turn your computer into somewhat of a chameleon. So you can basically get an Ubuntu shell quite easily. Yeah, so you can easily get, like open a Ubuntu, you can easily get an Ubuntu shell on your Fedora machine, and it's very tightly integrated, so it automatically shares the home directory and the devices and all of these things, so it's really seamless. The problem is just it doesn't provide any isolation at all. They are very clear about the fact that they don't want to support that, it just doesn't align with their goals, basically. And then in the past year, like, I don't know, hundreds, if not thousands of different things have showed up to try and sandbox the AI agents. I think people realize that it's super dangerous to run these things, so everyone is trying to solve the agent sandboxing problem. I cannot list all of them, I haven't looked at all of them, but I also don't think these things try to solve exactly the same problem I'm trying to solve. They really focus on sandboxing the agent, but they don't really care about the fact that the libraries can be compromised or the editor or anything. They are super focused on the agent, so I actually want a bigger scope than that. Here I've just mentioned two tools which exist for agents. The first one is interesting because it's made by the same person who makes Distrobox. That one looks super complicated. I haven't gone into that yet. And this is kind of what I mean by super complicated. So this is the architecture diagram for that thing. It probably works good. I just think it's probably also very difficult to set up if this is how it looks. So yeah, after searching, I couldn't find what I wanted. Basically, I wanted a tool that provides decent isolation. It doesn't have to be perfect, but at least something. And I wanted to be able to run my full editor inside it, and I didn't want to be forced to use VS Code forever. I want to use anything, really. And then something else I wanted specifically is strong protection for SSH keys. So I don't want the SSH key inside the sandbox environment. I want to have it outside of the sandbox environment so that nothing there can touch it. But then also, I mean, with many SSH agents, they just, so you can solve this problem with an SSH agent and just a socket between them, but many agents basically just automatically sign every request thrown at them automatically. So that doesn't really help, because then if something malicious is running inside the sandbox and can send a request of the agent, quite often it will just get signed. So then anything can, if you use SSH for your GitHub, for instance, anything can push to your GitHub, and then you have this problem I talked about where the compromised people keep spreading. So that's something I wanted to have. The solution I came up with is called Litterbox. So Litterbox is one tool with two goals. The first goal, as I mentioned, is I want to have isolation, most importantly, file system isolation. So I want to have just the project should have its folder with its files, and stuff running inside the sandbox shouldn't have access to other files. And then, of course, limited access to the devices and the network, etc., and also specifically protection for the SSH keys. Then the other goal I had is this dev container type idea where your whole environment is nicely documented with the setup and the dependencies in a Docker file, and you can easily move this between machines or perhaps even use it in your CI environment. So yeah, now for a quick demo. there isn't really time to set it up from scratch, so let's just do a quick demo here. Oh, that is too large. So here I will use an existing one. Now I have to enter the password to encrypt my SSH keys. So then what we can do here is we can ls, and we can show one directory up and one directory higher than that. And this is interesting because if we look here, in reality, this home directory exists here under home, Litterbox, homes, tumble. So this folder it can see, but everything above it is just not visible inside the sandbox, which is exactly what I wanted. Then I can also show here that inside the sandbox I can run a graphical application. So this is using Vulkan and Wayland. That all works nicely. Then if I try to perform a get operation, then this dialog comes up. So the SSH request isn't just signed automatically. I have to approve it. If I decline, then you see git fetch failed. But if I approve, then it passes. So the nice thing about this is if you ever see this thing pop up when you're not expecting it to pop up, it means you've been owned. So then you have to delete this container and move on. So yeah. So let's get a quick overview of how Litterbox works. I mean, it's not that complicated. It's essentially just a convenience wrapper for Podman. I don't do any low-level stuff. It started as a script, a shell script over Podman, and then kind of just grew over time. So the big thing here that it adds is this SSH daemon, which is a background process which is responsible for decrypting the key, having a Unix socket, and then listening for the signing requests and popping up the GUI whenever the requests come in. And you have one daemon process per Litterbox, so you can decide which keys are attached to which Litterbox. You don't have to attach all of your keys to all of them all the time. You can be more specific than that. And then another thing Litterbox supports is you can have multiple terminals inside the same container, the same session if you want. And that doesn't create multiple instances of the same container. There are actually multiple terminals in exactly the same session, which is something added recently. And that brings some complexity because then I have to do some bookkeeping to keep track of how many terminals are open inside the container so that I can actually kill the container once you've finished using it. That's not something you get trivially out of the box with Podman. You can get it easily if you don't care about the thing keeping running forever when you're done with it, but you require some bookkeeping to do better than that. So it's quite simple, and the architecture is documented well in the GitHub if you want to learn more. Then I also want to mention that I've recently added landlock LSM integration into Litterbox. So if you're not familiar with an LSM, so-called Linux security module, I mean, that's basically just a mechanism that extends the default access control mechanisms in Linux to be more sophisticated. So it goes beyond the simple user and group-based permission system where you can have more elaborate policies, if you want to call them, where you put specific restrictions on specific processes or files and how these things interact with each other. And the reason I wanted that, some people here can probably explain why that is, but it's generally considered that containers are not great for access control. Mount namespaces have a lot of loopholes when you try to use them for access control. So it's generally recommended to also use an LSM together with a container if you really want to make sure nothing has access to files outside it. So that's what I use an LSM for. Originally, I was delaying doing this for a really long time because I only knew about AppArmor and SE Linux, which are the two major LSMs. Most distros use one of those two. But that was kind of sad because those things are not compatible with each other. So if I wanted to support them, I would have had to write code to support both of them directly. SE Linux is incredibly complicated to work with, so that also sucked. So I was just putting this off a really long time. And then the other problem is, especially with SE Linux, you have to do a lot of different things. You have to create a policy, then you need to load the policy, and you need root permission for a lot of this stuff, and I don't want Litterbox to have root permission. So all of that sucked, but then I learned about landlock, which is great, because with landlock processes just sandbox themselves. It's literally just a library that you link into your application, doesn't need root permissions, and then the application sandboxes itself, so it can just restrict its own permissions, like which parts of the file system it has access to, which some network stuff as well. Currently, I only do the file system part. So that's really nice. If you do any kind of software on Linux, it's a useful thing to know about. Like if you do a web server, for instance, you can use landlock to easily have the web server sandbox itself so that it only has access to the folder where its files are. So if it ever gets compromised, it just cannot touch anything else. It has made sudo a bit more awkward, but I have a workaround for that at least. So then I want to be clear that there are a lot of limitations with Litterbox. It's not perfect. It has a lot of known vulnerabilities and holes. Some are fundamental, whereas some are a bit more accidental, I would say. The biggest fundamental one is that, this just uses standard container technology, which means that everything running inside the container shares the same kernel as everything running outside it. So if someone manages to find an exploit in the kernel, that's still game over. Like Litterbox doesn't help you at all in that situation. And it's similar with other shared resources like the Wayland server, etc. Then sort of an accidental limitation is that currently Litterbox is implemented in Rust and uses quite a few crates, which means that it is itself highly susceptible to supply chain attacks. That can theoretically be fixed, but at the moment it is a problem. And then another thing to mention is network isolation. Currently, Litterbox doesn't do anything sophisticated for network isolation. Basically, you can have network namespaces, and that's about it. Many of these tools, specifically trying to sandbox the AI agents, try to do something sophisticated here. So many of them try to do like domain-based sandboxing, to have like a type of firewall where they usually have a allow list, like which domains can the agent talk to. I haven't implemented something like this yet, partly because of time. I haven't had time to work on it, but also because I think it's a really difficult problem to solve fundamentally when you're trying to build something like this. To actually come up with a viable allow list is going to be really painful. Like you're constantly going to be running into the firewall, and then you have to add a new domain and add a new. It will take a really long time, and by the time you actually have a workable file, maybe there's so much stuff in there that it's become useless anyway. I think to do this right, you need something very sophisticated. Just a simple allow list isn't really the solution. And then a deny list, of course, is just stupid. How are you possibly going to list every single domain it shouldn't have access to? So yeah, and I want to be clear, Litterbox is not for running known malware. It's not anti-malware. It's not bulletproof. It's intended to be better than nothing, because most people actually just have nothing. That's sort of the default that most people run with, and I want to do better than that. So I use Litterbox daily for all my development. I have different Litterboxes for different projects with different dependencies. Then I run my entire editor inside of that. I do a lot of embedded work, so sometimes I attach different devices. That doesn't always work great, but I have that. Something interesting is that for a project, a microcontroller project I work on, I try to simulate as much of the microcontroller code on my PC as possible, so that I can verify things work and do automated testing without having to run it on the board. And that's interesting because using TUN devices on Linux, you can then essentially run the entire embedded networking stack on top of a TUN device and verify that it works, which is great. When you're running that normally, that requires root access, but when you're inside a network namespace, you don't. So that's quite convenient that inside Litterbox, this just works without root. And yeah, I also then use the same images in my CI/CD environment with some slight differences. And then lastly, I just want to ask people to get involved. So I have to be honest that this is not a project that I started working on because I wanted to work on it. It was more that I needed this, and I couldn't find anything that I wanted, so I built it because I needed it. But this is not really the area that I'm super passionate about, or passionate about at all, to be honest. So I have other passions that I want to work on. I do this because I have to. So if there's any of you out there who are very passionate about sandboxing and containers and security and you want to get involved, please reach out. I would love to have more maintainers who really like this type of stuff. The big thing that's missing right now is automated testing. So for various reasons, it's difficult to implement automated testing for this. It's not impossible, it's just difficult. And that's really holding back development a lot, because then I have to manually test everything when I make my changes myself. And when I get pull requests, I have to do a lot of manual testing to make sure that nothing has broken. So that would speed up development a lot. Documentation can be better. There's a lot of work which can be done to improve the security and hardening. So in particular, getting rid of dependencies would be great to make it more self-contained and secure. And then sort of a long-term thing that could be interesting is, I've mentioned that full-blown virtual machines are not what I want. They're too inconvenient. But micro VMs have become a very popular way to run containers these days. So I think there's definitely a way to re-implement Litterbox based on micro VMs to actually have stronger security, to have that hardware isolation. You can actually get graphics working and everything with that. It's just a much bigger job, but I think that's an interesting way forward. I recently had someone who tried porting Litterbox to Mac OS. Eventually, I had to tell him to stop because, almost none of the features worked, and by the end, I'm not even sure why he was trying to use Litterbox, because he was basically just using Podman at that point without any of the other stuff. But if this were actually based on micro VMs, you could much more easily run this on Mac OS or Linux. Windows as well, but for now, with the container-based approach, it only works reasonably on Linux. And then I don't have a slide here, but this morning we saw the presentation from Tilitus, so they've also contacted me to make the suggestion that I should try to integrate support for their T key with the SSH agent. So that's probably something I will work on at some point as well. So yeah, I might have a few minutes for some questions now.
I have some experience with Distrobox, and I wonder how do you handle the base image? Is it similar that you can basically take any?
Yes. So basically, how it works is you have this Litterbox files and then definitions. So for each Litterbox, you have a Docker file, and then this run file just has some. The run file just basically says which things are allowed. Certain permissions, so whether ToonTap is supported or not. And then the Docker file is just a Docker file. There are some things you need to comply with for it to work properly, but it's not much. So essentially, you can use whichever base image you want. It doesn't require much.
Okay, but you have to set up a Docker file in advance, so to speak, and then they'll...
I have a convenience to generate. So it has some templates built in. So I have some convenience to generate a starting point for you that you can then customize.
Okay. Mm-hmm. Thank you.
So I think you maybe halfway answered it at the end there, but I was going to ask, do you have support for proxying an SSH agent that's running outside of the container? So if you already have, say, a GPG agent that talks to a smart card.
No, I don't currently have that. The opposite does work, though. So, something I have done in the past is that sometimes I need to work on a remote machine for various reasons. So if I am inside the Litterbox and then I SSH into a remote machine, it will proxy the Litterbox SSH agent into the remote machine. But I don't currently have support for proxying your own SSH agent into Litterbox. But it's not, it's actually rather trivial. If you want that yourself right now, it's pretty easy because I do expose a setting where you can pass extra flags to Podman. So you can literally just mount the socket into the thing and it should work.
Yeah.
And adding a convenience for that is not many lines of code either.
No, because I would just attach the comment that you really should be using a hardware token for your SSH keys these days. And we had the talk this morning, right? That available, you have support, so it just becomes an SSH agent and it works completely like a normal SSH key, but it's on a physical thing you can pull out, or you can have you need to press it to do things that would pop up and ask you.
Yeah, no, that's very, very useful, but I think most people don't do that. This is already better than the default.
Are you familiar with the NixOS and the Nix package manager?
I am, yes, I am. At the time when I built this, I wasn't that familiar with Nix. I am familiar to some extent now, but I don't want to build this on top of Nix because then you force everyone to use Nix, whereas currently it uses Docker, which, I mean, a lot more people are familiar with that, and then you can use whichever distro you want, I mean, including Nix.
Right. So I really like Nix, so I think we should all just switch. But there's a neat, so you can do these development environments where you can declaratively describe what you have, what stuff, which is similar to some of the features you get from a container file, right?
Mm-hmm.
But there's this neat trick with the NixOS where you can, the only thing you need to boot Nix is the Nix store.
Yes.
Like the init script in the Nix store. So you can mount your Nix store from the host into your container, not your container, your virtual machine with the like Vert.io. And then you don't need to build a disk image.
Yes.
When you start up both a container or a virtual machine, you need to get your base image to boot off from. And when you change that, it sort of takes a long time because you need to like rebuild the image, right? But so this is like instantaneous when you mount this. So and combined with micro VMs, it gives you like super fast virtual machine thing.
Yeah, that makes sense.
If build that, I want that.
I mean, I think you can build something.
Yeah.
I think you can build something very nice specifically for Nix and NixOS, but I think the audience of that will be quite limited, so I'm not going to invest.
All right, one final question, and then we need to move on.
Most a sanity check. Can you run Litterbox inside Litterbox?
No, because this is a... No, you definitely can't, because it uses rootless podman, and having rootless podman inside rootless podman is kind of possible, but really difficult, because it drops a lot of the permissions which are required to actually set up containers normally. So, I mean, just podman itself already kind of throws away a lot. On rootless podman, it already throws away a lot of the stuff you need to actually create containers, and then with the landlock, it gets worse. So that's one of the reasons why it's difficult for me, or why I have not set up automated testing yet, is because I like to develop Litterbox inside Litterbox, but then I cannot run it inside the container, so it creates a problem there.
Yeah. All right, thanks. Thanks a lot.